So lastly, as I said, we looked at a new distribution called the sample distributions, a mean, and we said that if those means came from something that was normal, the new distribution will look like this. So if the old distribution was this, the new distribution is this. That's okay? So every time they ask us to find anything to do with mean, like for example, the question that we did last day, find the probability x bar is less than 2. What distribution we using? Distribution 1 or 2? We're using the distribution 2. Okay? So this is the mean that we're using, and this is the variance that we're using. Right? Just give me a little mind enough. But what do we do when we reach here? Standardize, right? We standardize. Right? We standardize 2 minus mu all over 6. Okay? Nice. So the reason we learned about that particular distribution was because we're going to ask a lot of things about mean. All right? So we have to use that new distribution. Today now, right, if you look at the examples we did last day, all of them came from a normal. Let's take a little glance now. Take a little glance at the 2 or 3 questions that we did last day. They all came from normal distributions. All right, today we're going to do a next case where the distributions are not normal. Okay? So when the distributions are not normal, we're going to use this. Right? So whenever we have a non-normal population, right, binomial, whatever, right, with a known variance, once we have a large number of values, here we can do, they allow us to approximate to this. And that theorem that we use is called the CLT, central limit theorem. Okay? So anytime you see a distribution and they ask us to find anything, but they do not give you the original distribution or it's not normal, you could say, well, since n is large, by central limit theorem, we could approximate it to being a normal. Right, McGills?
Yeah.
Yeah? Nice. Hey, where I don't have to share it. You should share it up. Oh, you win already?
Yeah.
But you win the popularity thing already?
Yeah. For sure.
Oh, but you didn't share it.
Did you share it?
Oh, okay. So you win the people choice today.
Yeah.
That's start. All right, nice. Nice. So copy down that little piece. Copy down part B. When the samples are taken from a non-normal population, but when I say that slide, just try to clear up the tables. When we call applied maps, it is called maps. You're doing statistics. Check the S and E. See if you get quick ones. Right? And you can find one. There used to be a site called Green Peoples. I'll stick them and I one of them now. Tell them to walk past people's topics from here. Right? And see what site said one and in document different.
So, okay, may I bring up a question to illustrate some methods in our environment?
Yeah, you know. Yeah, and this guy, I just but I explain systematic steps, explain stratified steps. Before the 5-1, when it comes tomorrow, Wednesday, right? Wednesday again from till 12 and then 2 till 6. Or you can try them home, take a picture where you have on site. Those will be rare not. Go. Right, so again, when we're using this is whenever we have distributions that are not normal. Right, put in brackets, n is normally more than 30, right? When they say large, n is like more than or equal to 30. Right? That's the value that they use to our reference, right? More than 30, they consider that large. Same sample. Same thing they come last. These are different keys. Ready? Let's try one now. In an examination taken, by a large number of students, by a large number of students, the mean mark was 64.5. The mean mark was 64.5. The mean mark was 64.5 and the variance was 64. And the variance was 64. Full stop. The mean mark in a random, the mean mark in a random sample of 100 scripts is denoted by X bar. X with a little line on top, right? X bar. It's denoted by X bar. Find the probability that X bar is more than 65.5. Find the probability that X bar is more than 65.5. Right? So first thing first, you have to define X bar. X bar follows on normal with mean, mu, variance, sigma squared on n. Can you help me out here? It's a normal, right? What does it mean? What does it mean they give you? 64.5. What's the variance? 64. And n is how much? 100. So that is our new variance. Our variance is no longer 64. It's 64 divided by 100. Okay? This is the distribution that we're using now. Yeah. Okay?
So right.
Where we which square? Remember variance is sigma squared.
Oh,
Right? Variance is variance they give you a standard deviation, right? Right. Nice. And they asked us to find what? The probability of X bias 65.5. Nice. Now we can go ahead and Joseph, how we do it? Standardize. So the first thing we're going to do is standardize. That's the probability of Z is more than value minus the mean divided by the square root of this value here, square root of 64 over 100. We're using this now. Do my little favor now, tell me where is that? Posing 1.25. Right? 1.25. Right? Remember, is more than and is on the right side. So therefore is 1 minus 5. This is from the table, right? Because it's on the right hand side is 1 minus 5 of 1.25. Come on, Zano. Huh? What this? Yeah. I just when I go to stats and go to normal, I just time about which one is the rest of them. But yes, we go take out the time the other one. So if you put in fire whatever they'll do. Even fire goes in. But you have to do this at normal distribution. That's one the calculate. That's time about which one. But yes, all those things, every table on that Casio calculator, even formulas. Like there's a way to pull out formulas and constants. We call it constants. All that you call it. So you don't have to always remember when it goes on constant or anything like that. How much is this? 0.105. Any questions online? Oh gosh, I leave out something. What did I leave out? I left out one thing. By central limit theorem. Right? Without stating the theorem, you cannot use this. Okay, so you have to state by central limit theorem. This will happen. And you can put in brackets, n is more than or equal to 30. N is more than 30. Keshav, you okay with this?
So he's trying to finish the.
Sure. Oh, we get.
What am I doing?
Keshav, I can't believe that though. All right, let's go again. Right, those who do in the SP last week's school will spend some time on that, right? But yeah. Try this next one. The mean of 50 observations. The mean of 50 observation of X, where X follows a binomial, where X follows a binomial 12, 0.4. 12, 0.4 is X bar. Is X bar. Find the probability, state the distribution and find the probability of X bar is less than 5. Find the probability of X bar is less than 5. Well done. Pressure. Right? Would we be using CLT, Joseph? It wasn't here Saturday, so I'll make up for it. Would you be using CLT here? And is what? And is what? And is 12? No. What do you mean? N is 50. So because N is 50, it's bigger than 30. So that means we could use CLT, right? But to use CLT, we need a what? A mean and a variance. Could you find mean and variance here? Given these two values? Check back fast for binomial. Check back for binomial if you could use the mean there. Sorry, not if you could use. How to find mean. Mean is what? N by P and variances. Right underneath it. Mean is NP and variance is NPQ. Go ahead. You have not this and then we're going to do a chemist question. Right, so finding mean NP. Oh yeah.
Interesting. I went to Hamilton. Wait. So. I mean, what's 7 years, so I think that. Do you really get 6 7? 7 9 6 7. Yes, I think.
Yeah. So.
What's that?
7 6. Shit, yeah, this one. I don't expect.
I done?
No.
No?
No.
I can give you a minute. N by P, that's 12 by 0.4. How much hours? 4.8. 12 by 0.4 by 0.6. How much this one was? 2.8. Right? So by central limit theorem, because n is more than or sorry, n is more than or equal to 30, right? N is large, right? It means that x will now follow a normal distribution, sorry, x bar will follow a normal distribution of mean 4.8, variance 2.8 over 50. Right? This is the new value that we're using, right? So they want the probability of x bar is less than 5. So the first thing we do is standardize. So that's z is less than 5 minus 4.8 all over the square root of 2.8 over 50. Probability of 0.83. So we have to find phi of 0.83. Right? Less than is all of this, right? 0.83. How much is that? 7 9 6 7. What funny ways of it? Copy them and then let's try this one here. Enough. Right, the C below means that Cambridge, right?
I guess. Well, there may be other people Skyway. It's still around. So you're going to start with.
Because we are doing our Saturday. Yeah.
Yeah, it's easy. Wasn't they jump dash enough to come down?
Okay, as we work, so how to be true. Emma do real work too. Ask them much.
So she's on. Like, so I don't think she might come up to. Extra.
Timer. Right, I want to give you a little help because the table might be a little tricky for you to figure out, right? So we had to create a table similar to a little while ago. What are the options? X is the number of white balls drawn before the first red ball. So what are the options for X? 0 red balls. Sorry, 0 white balls, or you could have 1 white ball, or you could have 2 white balls chosen before the red. Okay, you have to now find the probability of each one. Okay? That's what they're asking you for. Right? One is 1/3. You gotta figure out how to get that. Think about it. Zero white means what? Zero means what? Means that you get red one time, and it means that you get red one time. I'll help with that now. Ready? That's what you come up with. So the random variable being 0. So 0 white balls drawn before the first red. So if you're choosing 0 white out of 4, how much you have? No whites. So you have 2 of each, right? What's the probability of, well, if it's no white, is that you're choosing one? A red, right? So that will be what? 2 over 4. So the first one is 2 over 4. What's the next one though? Alright, let's leave out 1. Let's go down to 2 whites, because it might be easier to figure it out in next week. So what's the probability of choosing the first white? 2 out of 4, right? A half, right? And what's the probability of getting the next white after that? No replacement. No replacement means I took out the white and I'm leaving it out. It will be 1 over 2. So that's 1/6. So if it's a distribution table and the first is a half and the next is 1/6, what's the one in the middle? 1, 2. Right? So it's a half, 1/3, 1/6. And now finish out the rest. I don't know if it's school teachers is marked like that, but I remember if you got A wrong, when you use those values in A to figure out B and C, you'll get full marks, right? And you do it right. Error carry forward, right? But your school teachers mightn't do that. They might just give it 0, but they get A wrong. So be aware. So use that now and find E of X. How you find E of X again? Multiplying and then adding them up, right? And then find variance. And then find the sample of 80. Online, any questions? Any questions there online? $6 million actually. Oh, yeah, that's stream pretty quick again. No? I'm sure.
signal that reached
28, like the low something. Wait, they can't catch numbers. 3 and 3 is 6. Wait, they can't catch numbers. What's the point? The game feels it don't make sense then. Who will also? Oh, go in the front alone. I confuse Avery. I thought they could catch up. I'm just waiting for it. So done. Right, I'll do the last part and board, right? But what you'll get the E of X. Which and you got variance 359s.
Yeah.
Okay. So all I was really hard in this table was part B, right? Hello? Right done. So Nathan. So Nathan, what is the distribution we're using in part C? X bar follows up. Right, so That's by central limit theorem, right? What the distribution we using? So we're using 2/3 and sure. So just write 5/9 here.
Yeah.
So I'm missing. Who's singing right on the board? Over, no, not 100. Over 80. Over 80. Right? Over 80, right? And then it worked out. So it will be the probability of X bar is more than 0.75 and you work it out, right? Those who online message the values, please. If you don't mind. Oh, you up there? Haley, send something. Keisha, you too, Matthew. Right, finish off the rest. What you got? Right, don't forget to standardize. Right, 0.75 minus 2/3 all over the square root of 5/80 by 9, so that's 5/14. All right, you need to. Probability of. Probability of Z is more than what? 0.8413, which is equal to 1 minus 5 of that, right? Well, then get that? 0.8413, and then it's 1 minus 5 of that, right? Which is?
Those is, I want to say, you said I don't want. I said, you're pulling forward. Get forward.
With a loss.
So the file one, which is info.
So the value that's supposed to go here, probability of Z is what? What, 1?
Yeah.
So it's 1 minus. And you got 0.8413. All right. The next thing we have to look at, so that's basically how we handle those three things, right? The next thing we have to look at is something called point estimates, right? Remember I told you there are three things that we're going to use to make a conclusion. We're going to make a point estimate, so we're going to actually try to find mean and variance and proportion. The second thing that we're going to do is confidence interval, find a range where these values might exist. And the third thing is hypothesis testing. All right. So today we're going to just take a look at the point estimates, just formulas, right? I will show you both versions. My advice is that you learn to use the one on the formula sheet. Right. So here's what. Sometimes we have to do unbiased estimates for each one of these. Population mean, where do I estimate? Population proportion, where do I estimate? Population variance, where do I estimate? So in order to do that, we take the sample, right? And what you will recognize is that whenever you make these estimates, what we generally do is put a little hat on top. So this hat will tell me, so the hat on top there, that little hat on top there tells me that we estimated the population mean by using the sample mean. Estimated the proportion by using the sample proportion. We estimated the variance by using this here. Right. Normally the hardest thing is to use the find the variance, right? There are two ways that we can find the variance. Number one, ignore this here. Number one, if we find the sample variance, you multiply the sample variance by n over n minus 1. That's one option. Okay? Multiply the sample variance by n over n minus 1. That will give us the estimate. That will give us the estimate for the population variance. Or if we have actual x values, we can use this version of the formula. N over n minus 1, x bar squared on n minus. All right. There's a next version as well. Go to your formula sheet now. Oh, sorry. For those who want to write, although I gave it this right up now. Next heading is on the point estimates. There's something new, right? Point estimates. But I know based on the game, right? Then little so far, door. Cool boys are more updates than other. Press band, nil. So you know what I mean? It's a penalty. Pressure. Half time already. Now half time.
No, it's not.
Are you done? Oh, I will give. Right, actually just write it here, so I'm happy to go to the next. Right, the one in red is the last version. That's it to do give you mean, right? Which one? Sigma x, no, just sigma x over the n. I factor the n from the outside, n from outside here missing. That's why it's not all square. Right, so you have those three different formulas. This one, if they give you the mean, this one, if they only give you sum of x squared, sum of x, and this, if they give you sample variance. Right? That's my favorite. I just check the formula sheet of which one they give you. I think they give you one for group means, I think. Check the data sheet I gave you with the tables and things. If your school have the new version, like the one that came out 2021, 2022, then they get you. They have all these in it. But oh yeah, so sadly they only have the one grouped mean. Right? See F there, F mean group mean, right? So you don't have to do that one, right? So give it up. Yeah, you get that. Oh, you know your tables and like. So it's how is no 5 of 0.413? What just give it a table, alone. Oh, oh sure. So yeah, learn all this. As you tell me, Mikhail?
Yes, sir. What is Charlie?
Huh? Still what to what I'm doing? Wait, encouraging men to sit down and learn that Joseph come up before. Ready? So let's just do one. So Olia, these things are only going to give you values. These things are only going to give you like 4, 5, or 2.3. That's all. They are called point estimates for a reason, right? They're giving you a point estimate, a singular value as an estimate. The one that we're doing next will be the confidence interval. Well, I think I should tell you. Ready? Let's try one here now. I'm sorry, what is all about? Actually, they can draw any. The white estimate the variance and the mean. Don't worry the rest of the writing, right? Just calculate two decimal place unbiased estimate of mean and variance. But look at what they gave you. They gave you sum of x and wait, how many bars it was? A random sample of 50 bars. So they were nice for you and they gave you sum of x and sum of x squared. So just choose the right formula to find variance. I won't take it long, right? Help for it. Felix and getting knocked in.
So like, this is Hebrew no. Like, this is Hebrew no.
That which version are you using, McGill?
7-1.
Huh?
I use 0-1.
Oh, and where I get with the wrong one?
Negative.
That's very bad. That's very bad. But I'm glad you recognize it wrong. Right, so hopefully by now we have X bar. I thought it, so we just calculated these values, right? So when you understand the standardized denominator, it's supposed to be the root of. Wait, I get lost there. So, sorry, Sophia, I'm now seeing this. Yes, but it's be the root of the new variance if found. Right, Sophia? So it's the root of whatever the new variance you found when you define X bar, the root of that value. Right, Sophia? Which question it was earlier? From really long ago? Yeah, well, it could be the square root of that. So now what? From today? From today?
Lower and say what? It's also not even like.
Why not see? Why not something?
Right, but Sophie, all you have to remember is whatever the variance is, you divide it by n and then you square root that when you standardize it. Right? right? So I have X bar already. X bar is sum of X on N. So that's 738 over 50. How much all got? 14.76. Everybody okay with that? Yeah. So now we have X bar and we have sum of X squared and we have sum of X. So then we want to find variance. So can I squeeze that in here? Oh yeah, I give you some time. Choose the right one. Choose the right formula, work it out. So this. So you want to two? No, you can't leave this out because remember that there are situations where you don't know the variance, so you have to estimate it. Remember that? Unknown variance. So you're going to need this, right? You're going to need to estimate this. Well, good. I see you yesterday in the game. Wonderful. Huh? Almost. I
See, you report case, I'm going to.
you report team lose something.
Yes, your report.
Right.
If you right, that's not problem.
But I like what is real frustrating, man. But it's here also.
Yeah, but I teach almost.
Are you playing that game already, Mikhail? Right, Mikhail, help me out here. Sigma squared n over, tell me the formula to use. N over n minus 1 by what? Sum of x squared over minus the minus what? Right, but remember, we have the mean. So why do you use the mean squared version? Right? And plug in everything and work it out. I just squeeze it in there online. A little space there. So that's 50 over 49 by what is sum of x squared? 16526 all over 50 minus if you want, you do have to write 14.76, right? You could write 738 and 50 all squared. What that does is just reduces the average, right? What do you have to know context? Yeah, it was next one. How much all got? That's sigma squared, right? 100 and rest it 2 decimal places, right? All right. How you would find proportion? How you would find? I just asked an example, right? How you would find in this example here the estimated proportions of fives. What you would do? No, I didn't pick you. But you want to answer? Go ahead. I didn't pick you. You sound like you're the backside pick. Just pick you. So Mikhail is Mikhail. And now pick Jandiman, say pick you. Right? How you would do that? So we calculated variance, we calculated mean. How you would calculate the proportion of fives in? 7 count the number of 5 just see in there and divide by total. Okay? Real simple. So just do a quick estimate. What's the estimate of proportion there for 5s? Well, I guess 6.
It's about one,
What do you get up?
1, 2,
1, 2, 3, 4, 5. Well, I get 6 on that one.
The 6.
What's the 5 over here?
So,
Every circle. 1,
so 6 is
2, 3, 4.
number.
Oh, yeah. 6. I missed that one and second to last row. Okay. So the proportion from the sample will be 6 over 50. Okay? That's just way to understand what I mean by proportion. All right. Do I do the next thing now, going? All right. I don't want to rush the next thing. Next thing is called confidence intervals. You'll do that? Well, you're probably coming back to probably just run through it with the study SB. I don't know.
we do an escape next week too.
That's probably why he doesn't run into it.
Oh.
All right. I'm not doing this today, but I just want to explain something, right? Right. You also how you just found a particular value for the mean. Now we're going to, well, not today, but now we're going to estimate a range for mean. So you're going to have a lower boundary and an upper boundary. Right? We're going to estimate a range for the mean, a lower value and a higher value. Okay? And what we do is we use an estimate. So for example, if the question said, well, here's what. Can you create a confidence interval that's 95% sure of finding the mean within that value? So what you will do is you'll take the 95%, go to your normal table, find like a critical value, and then use that to help find the lower and the upper boundary. All right, I'm going to show you how where this came from next week. And I'm rushing that today. All right, so we're doing confidence intervals next in full. The only problem with confidence intervals is that when this sample is small, we're going to have to start to use something called a t-distribution. All right. So next week we do all that, or we could do a t-holiday and thing on the one. Right. Next week, if you want, you could just do a paper. Right. Oh, remember in the holidays, the class is kind of late, right? So there is an option if all the one the last week of school. That's the week with the 7, 8, 9, 10. That week there, we could do like 3 or 4 sessions and we replacing holidays. The other one. Right, so I do have to come the next week.